So now let's talk about adding and subtracting complex numbers. When you add or subtract them, you're basically just adding or subtracting the real parts and then add or subtracting the imaginary parts. So here I have three terms I am adding together. Notice that when I look at it, I'm going to add the real parts, which are the 2 plus 3 minus 2 here, and then the imaginary parts, which are 3i plus I, and then plus another I, to give me a total of 3 plus 5i. And it's the same concept if you were to subtract. So let's look at a couple of examples together. So here we have two examples we're going to look at. The first one, I'm going to add this first term, 3 plus 2i, to 9 minus 3i. And we're going to basically just add our real portions together. So 3 plus 9, which would be 12. And then we're going to collect or add our imaginary portion. So I have a plus 2i minus 3i, or just minus I. So it's pretty straightforward. Let's just practice this next one together. Negative 3 minus a negative 4, which would be a change for us. So in other words, negative 3 plus 4, which would be positive 1. And then we have 2i minus, I'm going to go back to a minus, so 2i minus 2i, which is just simply 1. So when I combine those two together, I just get 1. Now what happens when I want to multiply or divide complex numbers? Well, it's not that different. We're going to multiply two numbers together. We just have to remember, when I multiply an I times an I get I squared, which is technically negative 1. That doesn't come into play unless we're really talking about multiplying FOIL or doing the conjugate. So let's look at a couple of different scenarios or examples together. So here I have 4 examples which are just straightforward multiply or divide imaginary numbers. Let's start here. We have negative square root of 3 times negative square root of 8. When you're doing this, you want to be sure that you handle the negative portion before you ever multiply the actual numbers. In other words, this I can rewrite as I times the square root of 3 times I times the square root of 8. Now multiply their imaginary portions together. So I times I is I squared. And then under the radical, 3 times 8 is 24. But I squared is negative 1, and the square root of 24 should be 2 times the square root of 6. So 2 times 2 is 4, times 6 would give me 24. Now this is the actual solution that you're going to get. I have a lot of students who may fall for the trap that I want to go ahead and multiply these two numbers together first. So if I multiplied the negative square root of 3 times negative square root of 8 together, just as it was, I would end up with the square root of just 24, because negative times a negative is positive. And then the square root of 24 again is 2 times the square root of 6. But you can see that these two answers are not equal, so this is an illegal operation. Make sure you take care of the negatives before you ever multiply. Let's go down and let's work this division problem together, and then you can work the next two to check. So if I have negative square root of 24 divided by the square root of 8, again, handle the negative or the I portion, the negative portion first. So we're going to rewrite this as a simplified. So I'm going to pull that negative out as I. So I have I in the front, and then I'm going to write this as 24 divided by 8. And I can do that because once I pulled that imaginary portion out, the 24 and the 8 became like terms. They were both real numbers, and if that's the case, I can write them together under the same radical sign. And I do that because 24 divided by 8 is just 3, and so the answer to this portion would just be I times the square root of 3. Okay, so I have two more examples over here, each dealing with a multiplication and a division. You try these two, and then we'll compare our answers. Okay, so looking at this example that I hope you worked by yourself, we have negative square root of 5 times the negative square root of 15. Pull the i's out first. We are left with this portion here. Now when I multiply those i's together, multiplying the imaginary portions together, I get I squared. Multiplying the real portions together, I get 75. And to simplify that, I squared is a negative 1. And then the square root of 75 becomes 5 times the square root of 3. Now let's look at this division portion, or the division problem here. Pulling the i's out first, I end up with I times the square root of 30 divided by I times the square root of 10. Well, I divided by I is still just 1. Any number, imaginary or real, divided by itself will still be 1. So I then rewrote the real portions together underneath the radical, and I got 30 divided by 10, which is just 3, so that would just be the square root of 3. And that's how we're going to just multiply or divide these imaginary and complex numbers.